In this lecture, we'll cover the concept of pseudo force. Suppose this is a reference frame in which a body of mass m is kept, and this is the fixed frame. Now this reference frame is moving with an acceleration ax with respect to the fixed frame. Now in such cases where the reference frame is itself moving with an acceleration and there is a body kept in that reference frame, that body will experience a pseudo force which will be in opposite direction to the motion of the reference frame. Like reference frame was moving in this direction, accelerating in this direction, and the pseudo force will be in opposite direction to the motion, to the acceleration. Means if the direction of acceleration is in this direction, the pseudo force will be in opposite direction to this, and it is multiple of the mass times the acceleration of the frame, so max. So this mass will now experience a force which is max when you look it in the moving reference frame. So if I am solving a problem where a body is kept on a bigger mass, say this is m1, this is m2, and I move this body by applying some force, and suppose this body is moving with an acceleration a. The body which is now being kept in this frame, if I solve the problem in this reference frame, that is I take reference frame of m2 as my reference frame. Now this is moving with an acceleration a, so this body, smaller body, will experience a force of m1a in the opposite direction. Suppose the friction coefficient, this static frictional coefficient, is mu s between m1 and m2. I have to find out at what value the m1 will start sliding on m2. Now just see what are the forces on m1. The forces on m1 are m1a, which is the pseudo force, and since this force is trying to push the body in this direction, a frictional force will act on it, which is mu s, and the normal reaction n, and n was equal to m1g, so it is mu s m1g. So what is the maximum acceleration which I can give till such time the body doesn't move? So the maximum force which I can give is m1a is equal to mu s m1g. This is the equilibrium point, and slightly more force than this will move the body. So m1a has to be less than equal to mu s m1g. So acceleration should be less than mu sg for the body not to move, not to slide on the bigger body. Moment a exceeds mu sg, the body will start sliding on the bigger body. So then the whole dynamics will change. That's a different matter, but here I just want to cover the concept of the pseudo force. You can use this concept while solving problem 31 of chapter 6, the solution which I have also put on this channel. You can have a look at that.